phase shift. Thank you. All right. So determine the amplitude, period, and phase shift of each equation, and then we're going to graph it. So first things first, you want to remember that the amplitude is always whatever we have in front. And if there's nothing there, that's going to be a 1. And we don't think of it, if it is a negative, we don't think of it as a negative because the negative is responsible for a reflection piece there. And then the period, well, for cosine and sine, that's always 2 pi divided by the absolute value of b. So I look up here and I think, well, b is supposed to be what's in front of this x up here, and there's nothing there, so that's 1. So that's good news. We still have a period of 2 pi for this. I'm just going to use a lowercase p for that. And then we do have a phase shift with this one. And we notice that's attached with the x. And remember, x is always the opposite of what we see. So we look at that and we're thinking right, but it's not. It's the opposite. So that's going to be negative pi over 2, which is the phase shift. But we kind of think of that as here, we're going to move this to the left, pi over 2. So now, where to start, what to use for increments, all of that good stuff comes pretty easily if we remember that sine and cosine go from 0 to 2 pi, and what we're doing inside these parentheses is affecting that x plus pi over 2, because that's affecting that right and left movement. So we would go ahead and subtract pi over 2 from everything. And of course that means we're going to need a common denominator with our 2 pi. We write that as 4 pi over 2. 4 pi over 2 minus 1 pi over 2 would be 3 pi over 2. So our new graph will really start at negative pi over 2 and it will end at 3 pi over 2. But I need to know the increments so that I can get a graph that's supposed to look the way it's going to look. And that comes from the fact that the period for this graph was still 2 pi. And we still want this in fourths. So we're still going to take 2 pi times a fourth to figure out how far we should put in between each one of those points, which are the increments. And here the 2's will cancel and we'll see we have pi over 2. Now, pi over 2 from what? Well, remember, this is our new starting place, this negative pi over 2. Let me get a new sheet here. I don't know how you guys are for space, but I need more room there. So that's where I know that I have to start. So now I start thinking, okay, well, it was the 2 pi divided by 4, which is still pi over 2. So I'm going to have to add a pi over 2 to get to that next position that I have to graph. So negative pi over 2 plus pi over 2 would be 0. And then I have to keep adding that pi over 2 until I get to 3 pi over 2. Well, that's going to be pi over 2. And now we keep adding a pi over 2. And pi over 2 plus pi over 2 will be 2 pi over 2, which is pi. Remember, it was 2 pi over 2, so 2 pi over 2 plus 1 pi over 2 is 3 pi over 2. Here's what I do. I take a look at all of those that I have in the boxes, because those are the ones I have to graph. And I take whatever I would use as a denominator, but actually we have to take the greatest common denominator for any of them in the future. And we've got 2's, 2's, and 2's, 1's, and 0 for the other position here. So we can just go ahead and go by halves when we graph this, which is what we were technically doing before anyway. Whoops. So backing up, I'm going to put a little negative pi over 2 here. And now that's an important spot. And when we have an important spot like that, sometimes we want some helper lines to remind us of those things. So what I'm going to do is I'm going to put a little helper vertical line here. Remember, dashed means it's not actually a part of the graph. It's just something that's going to help me remember that's where this graph is going to start. And then over here, nice little pi over 2, 2 pi over 2, and 3 pi over 2. And now that would give us 1 period. And this one didn't say we had to graph 2 periods, but we like to see a little bit more. So maybe we'll go ahead and put a couple on the back side here. and see what we can do. So now it's about whether or not this is cosine or sine, and this is cosine. And cosine starts high. Remember, that's our kahala. So high axis, low axis. But this is a 1/2 this time. So you could make this a 1, or you could say, you know what, I'm going to leave myself a little bit of space so that I have something decent to use for that 1/2. And then we start, because it's cosine, right at this -pi/2, because that was our phase shift. But we have to remember the high for this one is only going to be 1/2. So we're actually starting there. Bless you. Now, cosine is high, axis, low, axis, high. And remember, we're shooting for that 1/2. We're not trying to go all the way up to 1. And then you could either right away start going backwards with it for just a few, or you could finish up that little portion of the graph and then go after it, going backwards. Again, it didn't say that we had to graph 2 periods, and when it doesn't, generally 1 period is enough. We've got a little bit more than that, so we should be okay. All right. Next one down. We'll start again with amplitude, period, and phase shift. So take a look at B. What's our amplitude? 1/2, right. Don't take the negative with it. The negative we definitely want in the back of our head, so we're going to put reflect over the x-axis, so we don't forget about that. All right, 2π/b for the period. What's our b value for this one? 1. Still 2π. That's good. But now we have to have a phase shift also. So the phase shift is how we're affecting our x. Where's this going? -π/4. -π/4. And in our heads again, we're saying, okay, that's going to be left. All right, so this 2π divided by 4 again will still give us a π/2, but we're now starting at -π/4. So I start doing this process and I realize, well, it'd be really helpful to have it in fourths since everything's in fourths. So instead of writing π/2, 2π/4 would be more helpful. And you can think in terms of that as you're continually adding to get the increments that you need. So we have a -π/4 plus 2π/4, which is going to be 1π/4. So that would be the next one we would graph. And then we're going to have to add our little 2π/4 again and get 3π/4. And add our 2π/4 again and get 5π/4. And at this point, I'd say, okay, how about that inequality stuff that we were doing? And remember that this time, this one had x plus π/4. And that tells us we're going to have to subtract π/4 from all 3 positions. So you need to think of 2 as 8π/4 minus that π/4. Or, you remember, you're going to have 1 to start with, 1 to end with, and there'll be 3 in the middle to break it into 4 wedges. Either way, most people really like the inequalities because it'll show you, hey, here's where you're starting and here's where you're ending. So we need 1 more of these. 1, 2, 3, 4, 5. And we know we're landing where we're supposed to with that 7π/4. But we can't go by π/2 this time because everything that we see up here that's in a box is over 4. And those are the things that we need. So now when we go back to our graph, we want to change our intervals so that we're just talking about π/4. And here's the problem with me graphing this stuff up here. If I try to cram them in for each line, 1 pi over 4, 2 pi over 4, 3 pi over 4, you're not going to be able to read them all. But that's really what we should do, is just label each and every one. So I'll do pi over 4, but I won't write down 2 pi over 4. 3 pi over 4, I won't write down 4 pi over 4. 5 pi over 4, 6 pi over 4, 7 pi over 4. That's where we were supposed to end, right? But now we know we have to back up to the left, pi over 4. So I can do the same thing back here. Even now I'm seeing that's going to be hard for you guys to read in the back, but use those same intervals, just going to the negatives. Now I think, helper line for where we're supposed to start. Where should that helper line go? Negative pi over 4. Does this one start axis or does it start high? Axis. So this one is going right on our axis right here. But now we have to be careful. We've got this 1/2 going, so yeah, let's label it the same way we did last time for that. But it's a negative. So because of that reflection, instead of going axis high, we have to go axis low for that reflection. And our next one was pi over 4. Axis low, axis high, axis. Is it starting where we said it was supposed to start? Is it ending where we said it was supposed to end? We said negative pi over 4, 7 pi over 4. That up here so everybody can see that. And then put a few points on the left just so that we have something nice to look at. And create that nice smooth curve. So we had one cosine and one sine. We talked about those increments. We're going to go on to some other stuff. If we have time at the end, I'll come back. I can't. There's important stuff here. Shoot. Here I was going to try to jump to something else. Can't do it. We got to do these. Do you see why? Yeah, we got to pull the 2 out. That's why. So if we have something, a new piece here to take care of when we're graphing, that's going to affect our period. So amplitude of 4, I know everybody can handle that. That means we're going to go up 4 and down 4. It's going to affect our range. But our period now, 2 pi over the absolute value of b, we finally have something that's not 1 that we have to put in here. Here's our little b. So this one's only going to have a period of 1 pi. Still has a phase shift. What is the phase shift? Pi over 6, right? We have to look at it in that factored form so that we can see that piece. So pi over 6. Now, sometimes people have a little trouble with factoring out that 2. Remember, what we're really doing is we're cutting these in half when we factor that 2 out. But now that 2 also tells me that this is going to be a horizontal shrink. Because remember, anything with the x works backwards from the way that we normally think of it. And that makes perfect sense, given that now instead of 2 pi, we're going down to 1 pi. Makes perfect sense. But here's the big deal. We can't use pi over 2 for our increments anymore. Now we've got 1 pi, and if we divide it into fourths, it's going to be pi over 4. So our new increment is pi over 4. We're going to start at pi over 6, but we have to use increments of pi over 4. So again, start thinking, common denominator wise, well, pi over 4 probably isn't the best thing, but we'll see it gets different with this through it. So we definitely need this. And we think common denominators and realize, well, this would be 2 pi over 12, and this one would be 3 pi over 12. So my next one is going to be 5 pi over 12. So just kind of sight visually helping people to see, hey, this is what we're going to need. Well, now we've got to add pi over 4 again. And we realize, well, that's still going to be 3 pi over 12. So now we're at 8 pi over 12, but we probably want to reduce that because 4 goes into both of those. And we're going to add another pi over 4. So with 3 and 4, we're going to be looking at 12 again. So we had 8 pi over 12 plus 3 pi over 12. 11 pi over 12. One more, or we look at that inequality piece. Pi over 4 is another 3 of them, and that's going to be 14 pi over 12, which will reduce by 2's. So now let's see if that was where we're supposed to end here. So we go back, and this one had 2x minus pi over 3. And let's see if that was where we were supposed to finish up, was 7 pi over 6. But we're going to have to add pi over 3 to all 3 pieces. And we'll have to have our common denominators. So we'll need 6 pi over 3 for 2 pi. And then we add one more and we get 7 pi over 3. And then dividing by 2, if you're working with fractions, you might as well just multiply everything by 1/2. So this will be pi over 6 less than or equal to x less than or equal to 7 pi over 6, which is exactly where we ended up. So now, what's our biggest denominator for all that stuff in the boxes? 12. Ew. All right, so we're going to have to go back and do 12ths and hope we can get enough to see one period on this thing. Again, I won't write them all, I won't label them all. Now notice that I put that label down a little bit lower. Think back to the original. Why would I do that? Oh, no, 4. Exactly. Has to. So I've got 1 pi over 12. I won't label 2 pi over 12. 3 pi over 12 would reduce to pi over 4. 4 pi over 12. 5 pi over 12. 6 pi over 12. I'm not going to label, but 7 pi over 12. There. 8 pi over 12, not going to label. 9 pi over 12 would be 3 pi over 4. Yeah, 3 pi over 12. 9 pi over 12. Yep. 10 pi over 12. 11 pi over 12. That's beautiful. So 1 pi over 12. 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi, and I'm not even going to be able to get to the one I need, which means it's really important that I put some of these negatives on here so that they can see, hey, this is a continuation. I can get at least one full period out of this. All right, helper line, where's it going? Our helper vertical line. Pi over 6. Okay, so I think, well, that was 2 pi over 12. That's going to be right here. Do we start axis or do we go high? pi. This is cosine. So let's get our labels on there. I'm just going to put a 1 here and a -1 here. I've got enough labels all over the world anyway. But we have to go up 4. Okay, now help me out. What was the next label that we had for this one after our pi over 6? 5 pi over 12. So now we're here. The rest of them, you can just kind of think, if all of this is going to be symmetric, I'm going to have to go 3 over and 4 down. So now I'll go 4 down and 3 over. And that landed at 8 pi over 12, which would be 2 pi over 3. Was that the next one that we had? It was. So use that symmetry. And again, that's not one full period, so it's important that we're going backwards on this one. So I'm just counting 3 over, 4 up and down. So. Okay with that one? That was a lot to keep track of, right? Imagine now that there's a negative in front. Now we just keep getting new pieces. All right, so let's try this one. Hopefully it'll be a little bit louder telling me what to do here. So let's do amplitude for D. What is it? 4. All right. The period requires us to do some factoring. What do we have to factor out? 2. So what's going to be in those innermost parentheses if you factor out a 2? All right, so our period will be 2 pi over what? 2. So we're back again with pi, which means we're going to use increments of pi over 4. All right, next up, phase shift. What's our phase shift? Pi over 3. All right, so we're going to start this graph at pi over 3. We need our increments. Our increments are going to have to go by pi over 4. And you know what? I think I've got some room down here finally to do my inequality on this page. So the normal period for sine is from 0 to 2 pi. Well, we're going to have to add 2 pi over 3. Which would be 6 pi over 3. So 6 pi over 3 plus 2 pi over 3 would be 8 pi over 3. And again, since we're working with fractions, instead of dividing by 2, think of it as multiplying everything by 1/2. So this says we're supposed to be starting at pi over 3. Of course we are. There's our phase shift right there. We're supposed to start at pi over 3. And thanks to the new period for this one, we know we have to add pi over 4. All right. So least common denominator for 3 and 4, everybody. 12. So there's 4 of them, and there's 3 of those. So 4 plus 3 would give us 7 pi over 12. Plus pi over 4. Don't reduce it. Tell me what you get. 10 pi over 12. Now reduce it in your head. 5 pi over 6. Plus pi over 4. Now there's a reason I said don't reduce it in your head. It's going to be easier to go back now and think of it as 10 pi over 12. 10 pi over 12. Add that pi over 4. What do you get? 13 pi over 12. We done yet? No, we're not to our 4 pi over 3. So we've got 13 pi over 12. Tell me what you get, don't reduce it. 16 pi over 12, now reduce it. Is it working? 4 pi over 3. That's our biggest denominator. Yeah, we're stuck again with that 12. Ugh. All right, so let's put our labels on there just like we did the last one. Go far enough down for the labels. Right over the top. Vertical helper line goes where? Okay, but we're going to need to change that into 12ths so we can find where it's supposed to go. So pi over 3 is what in 12ths? 4. 1, 2, 3, 4. So there's our helper. We start in axis or we start in high? Sahala, sign is axis. Axis high, how high are we going to go? 4 units. Oh, where is our next one? Let's look in our boxes. 7 pi over 12. Yeah, same thing as last time. Do the 3 over 4 up piece. Right? So we haven't done yet. We haven't moved it up or down. We still have one more thing to do. Lots of good pieces though. Lots of good pieces because this is going to help us as we get to that part of, okay, what happens if we translate this vertically? Where do we go with it? Well, basically, we just do this and we move it. That's all we do. You know, that's why we learned all of this first. All of this is going to hold, but we just move it. And we're going to put another helper line in for that. So if they say move this down 3, we're going to go to -3. We're going to put a helper line in here and make that our new axis. But it's very, very similar to what we're already doing. So that said, yeah, we still have to add K. Enough with the letters. We had A, we had B, we had H. Now we have K. So K is the vertical shift, the up and down shift. And it is just exactly what we were doing, except basically moving the axis. Moving the axis up or down according to K. Now, K is not affiliated with X, so that means whatever we see for K is what we use. If it's positive, it moves up. If it's negative, we move it down. And like it says, think of moving the x-axis up or down. We're going to move that new axis and put in a helper line. And now the graph will oscillate about that line, whatever y equals k is. That'll be our new axis for that sinusoid. Now, the range of a sinusoid in standard transformation form, y equals a sine b times the quantity x minus h plus k, or same thing but with cosine. That is given by that k minus the absolute value of a and k plus the absolute value of a. Oh my gosh, what on earth are they talking about? I don't ever remember that formula. Who needs that formula? Here's what you do. You think of it visually and you say, okay, they moved my axis down this way, or they moved my axis up this way. but my A value tells me I have to go up and down the same amount. And you can just do it visually without having to memorize any new formulas. Where's that new axis going to be? A tells me how far up I need to go and how far down I need to go, and that's my new range, and you can get it that way. So this says we're going to determine amplitude, period, phase shift, and vertical shift. Find a range, a new piece, and then we're going to graph it. We're going to continue with the graphing piece here. So let's just do these the way they said. A is 4. Period. 2 pi over b. What's b? 3. So 2 pi over 3 is our period. Next thing up, phase shift. Nothing. Yeah, I like that. It's one less helper line to worry about. So phase shift, we don't get one. I'm just going to put 0 here because it's not moving it right and left. 0. Vertical shift. Down 2. So new range. All right. So I'm going to go down to -2, and then I have to go back up 4. So if I was at -2 and I go up 4, where am I landing? At 2. All right. Now I'm back to -2, and I have to go down 4. Where am I landing? -6. So we'll use that interval notation, and we'll use those square brackets to say here, right here. Then we're done. How to start? Well, let's put that helper line to move our axis down to -2. So we don't forget about that. And I am going to go by ones. But we need increments again. You know, we need all of that good stuff. So take a look at the period. Oh my. 2 pi over 3. Okay, I need 1/4 of 2 pi over 3 for my increments. Well, thank goodness there's a little reducer that goes on there with the 2's, but our increments are now going to be pi over 6. So, I fit my inequality up there. Oh, we have a 3x. That's it. That's the piece we take. That's what's affecting our x. So 0 is less than or equal to x, which is less than or equal to 2 pi over 3. All right, doesn't sound so bad. I need some space. I don't have space. So I have pi over 6, and I'm supposed to keep going. That's my increment. So 0 plus pi over 6. I'm just going to have to shove these down for a second. I'm going to try and do this one without writing all the little things down, okay? So we start at 0, then we know our increments are pi over 6. 0 plus pi over 6 is pi over 6. Add another pi over 6 and reduce it for me. Go back to your thought before you were reducing it and add another pi over 6. Reduce it. We added 1 pi over 6. This was 2 pi over 6. The next one will be pi over 2. 3 pi over 6. Add another one. 4 pi over 6, which reduces to. Is this where we were supposed to end? Because there's 5 of them. Excellent news. All right, give me your biggest denominator. Let's use 6. 1 pi over 6. 2 pi over 6. 3 pi over 6 would be 3 halves. 4 pi over 6. 5 pi over 6. You probably want a little bit more than that. 6 pi over 6. 7 pi over 6. 3 pi over 6. 9 pi over 6 would reduce to 3 pi over 2. 10 pi over 6. 11 pi over 6. Hey, what happened to the vertical underline. Didn't need it on this one, right? No phase shift. Okay, so, all right, scroll down so far, it's hard to remember what it was. It was sine, and it has an amplitude of 4. So we starting axis or are we starting high? Sine is axis. But now instead of thinking I've got to go all the way up to 4, think I've got to count 4 up from my next position, which was my pi over 6. So 1, 2, 3, 4. And then our next one was pi over 3. Just trying to see these a little bit better. And that would have been 3 pi over 6. Our next one was pi over 2. And again, think, okay, now I've got to go down 4 from the axis. And then we had our 2 pi over 3, which would have been 4 pi over 6. So axis, high, axis, low, axis. Like I said, it'd be nice if we had a few more. I don't need to fill it all the way up. At the very least, we do 1 period. If we do more than that, that's fantastic. Well, that was beautiful. 1 of 4, everybody. Golly. All right, so let's do this. Take a look at B. Give me your 4, 3, 2, 1, 0 on how you feel about doing B all by yourself. Well, we're not doing it by ourselves then. All right, let's take a peek. Too much to keep track of? All right, let's take a peek. 3 sine 2x minus pi over 2, all of that minus 1. Start at the beginning. What's A? 3. Can't get the period without factoring this, so go ahead and factor it. So you pull the 2 out. Everybody getting x minus pi over 4? Okay. So now our period equals 2 pi over what? 2. That's not so bad. Okay, so 1 pi. So I start thinking increments. That's going to be pi over 4. All right. This one has a phase shift with it. What's our phase shift? Pi over 4. So now, let's see if we can figure out, oh, we better talk vertical thing first before the range. So, vertical shift. Where's it going? Down 1. All right, so let's visualize that range. We're at 1. Down 1, negative 1. Sorry, I should say negative 1. And we have to go up and down how many? 3. So negative 1 plus 3 gives you your high number. That's negative 1 minus 3. So we're going to go by ones. Let's at least get the helper lines on there before we forget about them. Down 1 is our new axis. But this one also had a phase shift. Well, we need to figure out where we're going to have to go with it then. It's going to start at pi over 4, but we're not sure if we should use fourths, if we should use 6, if we should use 12ths, because our period was pi, which means we're going to have to continually add pi over 4 to get that fourth piece. So phase shift of pi over 4 plus pi over 4 and a nice common denominators, 2 pi pi over 4, that will reduce to pi over 2. Add the pi over 4, what do you get? 3 pi over 4. Add another pi over 4, what do you get? Pi. Add another pi over 4, what do you get? 5 pi over 4. How do we check and make sure that that math is right? We need to know. What's another way to get that starting in the inequalities? All right, so what we had with this one was 2x minus pi over 2. So we'll add pi over 2 to all 3 positions. So we'd have 4 pi over 2 plus 1 pi over 2, which would give us 5 pi over 2. Again, instead of thinking division, think multiply everything by a half. Looks good. That verifies that our fractions when we were dealing with pi were right. And that's the part that most people are really uncomfortable with, is dealing with all of those fractions with pi. So, what is the denominator? What should we use for all of these? 4. Yep, that's our greatest denominator there. So, 5/4. Yeah, let's see, I'll try to squish it down here. So, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, etc. Now, what got me started on that anyway? What else was I trying to put on here that I needed that information? Helper line, my starter line, yeah. So my pi over 4. Right there, so I've got my new axis. I'm just going to think of it that way. And again, look at it and say, hey, I need an amplitude of 3. Don't forget an amplitude of 3. Are we starting axis or are we starting high on this one? Axis. This is sine, so we're starting on axis. And then we go high to the next one that we had on here, which would have been pi over 2, which is 2 pi over 4, and we count 1, 2, 3. And then we realize, well, this one will be on the axis. 1, 2, 3. Axis. 1, 2, 3. Axis. And we can again verify our range too. We can see that we have values for our y from 2 to -4. So there's 4 of these. All right, well, we can get at least one of them done, huh? So let's pick. I think you could do C on your own. Take a look at C. What's the amplitude? Period. Pi, so what would you use for increments? Pi over 4, okay, and down 1. I think you could do that one yourself. Let's do D. This one's a little weird. Looks a little weird. Alrighty, so amplitude. Period. So 2 pi over 1, that's still going to be 2 pi, right? Okay. Oh boy, what else did we want us to do? Amplitude, period, phase shift. What do we have for a phase shift? Pi. All right, then the next thing they wanted was the vertical shift. Where's it going? 1. All right, so we need to talk about the mean range. We went down 1. We're at -1. The amplitude is 1. So what's our range going to be? 0 to -2. Which we need to write as -2, 0. That's with the number line matching our equals there. All right, well, if our period is 2 pi, what are our increments going to be? I have a worksheet for graphing for you. You can grab one on the way out. So get it over here. Just graph it. And dot on black. Oh, we're working. Oh. Brad, what's your graphing? This. Okay, so what's the point of doing this week? It didn't make sense because visually, if we went by different increments and we didn't have our 12s and all that stuff on that, it wouldn't work as straight out as. But the week only here. We've done that. It's one of the things the three of us talked about. And we talked about that.
So I can put these on the number graph. Okay, good stuff. And then, okay, for range. For some reason, it didn't make sense to me because we're doing A minus like with, after the value of
This is K.
Yeah.
And then 8 comes by part of that. So you can think of it as, take this and add 8 to get up to the top.
Yeah, so it'd be -1 plus or -3. So it would be -1 -3 then? Yeah, because in the, or, -1 plus 2, so that would just be it 2. Okay. So for some reason, whenever I was doing it with computer, that's like,
Oh, no, okay.
Are you busy during your part?
I am, are you just coming to take your test?
It would be, I have questions on 2 of the assignments, and I'd be turning in all of those except for the reviews and reviews tonight.
Come on, we'll get you there. Yes, please do. Today we have a graphing trigonometric functions worksheet for homework.